So what happens when ReLU fails? ReLU is one of the most widely used activation functions in deep learning, and its rule is incredibly simple. If the input is positive, keep it. If it is negative, make it 0. But that creates an interesting problem. What happens if the neuron keeps receiving negative value? For that, let's first understand what ReLU actually is. We know that ReLU is max of 0, x. That means when the input is positive, we get the same as output. If it is 0, we get 0, and if it is negative, we get the output as 0. So here's the graph of ReLU. That is negative, and for negative the output is 0, and for positive it is as it is. So on the positive side, ReLU behaves like identity function, and on the negative side, it completely flattens out and the output is 0. And the flat region is where this region, the problem begins. So during training, neural network learns using gradient and back propagation, right? So for ReLU, when the input is negative, the gradient will be 0. That means no gradient signal is coming through this activation from that region, from this region specifically. So if a neuron consistently receives negative inputs, it can get stuck producing 0. The neuron may effectively stop learning, and this is commonly known as a dying ReLU problem, right? To counter this enters the leaky ReLU. Now, so what if we don't completely kill the negative side? What if we just let a tiny amount pass through? That's the idea behind leaky ReLU. So we have this plot. For positive we have identity function, and for negative, instead of getting the 0, we give it a tiny slope. So now instead of negative being directed to 0, we kind of give it a alpha as a very small number and multiply it by negative. So for example, if alpha is equals to 0.01, then if input is -5, then its output past leaky ReLU would be -0.05. So the negative side now has a small slope instead of being completely flat, right? So that's the whole function, and this can be described using piecewise function as, let's say, leaky ReLU would be x if x is greater than equals to 0, and it would be alpha x if x is less than 0, that is negative. Positive values are passed through unchanged, negative values are scaled by alpha, and because the negative side now has a slope of alpha, the gradient isn't completely 0 there, and that's the leak in leaky ReLU. Now that we understand the math, let's implement it in Python. So as we know, we have to simply give it a piecewise function, and that would translate to something like this: return z, because our input over here for this leaky ReLU function is z, and the alpha value, which defaults to 0.01, is determined by alpha. So we would write z if z is greater than equals to 0, else it would be alpha z. Let's run this. Okay, we haven't written this. Great. Submit. Yeah, that's it. Now we know how this function works.